Hi. Oh, hello. Greetings. Welcome. We're talking today about solving quadratic equations by factoring. So far, we know how to do this by graphing, finding the x-intercepts of the parabola, and knowing that blah, 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 it's a solution, right? But today we're going to talk specifically about solving by factoring, which means the problems will have to be solvable by factoring, and not all quadratics can be solved using that technique. But this is the idea. Let's say I've got this particular quadratic. 4x squared minus, let's say, I don't know, 20x equals 0. All right? Now, what I'm going to do is, this is the concept, you set the quadratic equal to 0 if it is not already. All right? Then we're going to factor the side that is not 0 and set each factor equal to 0 and solve those separate equations. So to factor this left-hand side, what would you think you would do? Yeah, GCF is the best strategy to use. I like it. So I can steal a 4x out of both of those. Well done, well done. So I'd have 4x parentheses x minus 5 equals 0. And so if these two things multiply to be 0, one of them, or both of them, has to equal 0. So 4x equals 0, or x minus 5 equals 0. If you really want, you could even draw little arrows where you kind of break this up into two separate equations, kind of like when we were doing absolute value equations and inequalities. And now I just solve each of these separately. So div 4, add 5, and behold, solutions, not unlike that of a Rubik's Cube being solved. Come out, just like that, bam, and I get two answers. Now if I change this to the equation y equals that, and I graphed it, and I found the x-intercepts, these would have been the x-intercepts. All right, just so you know. So that's the idea, solving by factoring. Now, in order to do this, I'm using a concept called a zero product property. And I know you've seen this before, but I'll still talk. I don't know. I wonder if zero and product are hyphenated. I could see that being the case, maybe. I'll call it the old ZPP, you know, classic. When you're doing math on the streets, that's what we refer to it as. Z to the p squared, you know what's up. And what it says, if a times b is equal to 0, then a equals 0 or b equals 0, right? So that's the zero product property. So that's why it's helpful for us if we can write a quadratic, in this case, as its factors, because then I can set each factor equal to 0. Now, a little bit outside the box concept, this is really abstract, I almost like to think about equality to 0 is distributive over multiplication. What? That is super weird, but it's true. So either a equals 0, right, if I distribute it to the a, or b equals 0 if I distribute it to the b. That's like so not at all mathematically a way to talk, but I thought it was kind of like an interesting, like, sort of concept. So let's do another example. What if I have the following? 2x squared plus 5x plus 12 equals, let's say I've got x squared minus 3x. So, currently, I do not want to factor the left-hand side. If I did, why would it not be helpful to us? Because it's not equal to 0. So step 1, let's set this equal to 0. Good job, Hank, and good job, Jacob, for complimenting someone on their good job. And good job, Mr. Waddy, for acknowledging students and their positive behavior. That was a little bit self-congratulatory right there, but I guess I shouldn't boast. Sorry. So let's set this equal to 0. Here we go. X squared plus 8x plus 12 equals 0. And how do I factor that bad boy? Well, it's not a pattern, because this isn't a perfect square. It is not an AC problem, because the leading coefficient's 1. So I can just find the factors of 12 that add to be 8. Bam. 1 and 12, 2 and 6, 3 and 4. Oh, I do as well. It's a good choice. So what does this mean? This means x with a 2 times x with a 6 is equal to 0. Don't forget your equal 0. I do find that students forget to keep writing the equal 0 for a while. Like they would have like maybe had it here, and then they'll do a bunch of work without it, and then like suddenly it magically comes back. So let's see. Oh, here we go. So let's figure out the signage on these guys, the polarity.
They're pluses.
They're pluses because they multiply to be positive, so their signs are the same. They add to be positive as well. I can't add two negatives to be a positive, so they must be plus and plus. Now, I'm not done yet, okay? What I'm going to have to do is zero product property this, right?
X plus, or 0, X, 0 plus, X, X plus, and then it's X.
Exactly. So, what I do is I've got two things that multiply to be 0. Therefore, either this was 0 or that was 0. And now I solve both cases. Subtract 2, or subtract 6, whilst I have my secondary color selected. I might as well do both. And x equals -2 and x equals -6 are my solutions. Hooray, friends! All right. Now, question, how many solutions would I expect a quadratic to have?
4, but it's actually 2. I always think quad like a 4-wheeler.
I know. You're right. But yeah, it turns out the number of solutions it could have is as many as 2. And since these are directly related to X-intercepts, I want to point out that how many X-intercepts does a parabola have? Does it have to have 2?
1 and or 2. Or can it have 0?
It could have 0.
From 0 to 2. Can it be like
So from 0 to 2.
straight line?
Well, a parabola is just one direction
So
change.
it can't be like,
No, so it can't hit more than 2. But eventually, we'll talk about situations where you have 3 X-intercepts or 7 X-intercepts. Just you wait. Next chapter coming up. So guys, check this out. I just want to point out that not all problems are going to have 2 solutions. In this case, when I set this equal to 0, x squared plus 10x plus 25 equals 0. Now, to factor this, oh, wait a minute. Oh, wait a minute. Oh, wait a minute. Keep waiting that minute that I told you to wait. This is a pattern problem. What? So you should keep your eyes out still for patterns, right? Perfect square here, perfect square there. That's what made me suspicious. But let's now check whether or not the middle term is the 2ab. Let's see. Well, a would equal x, b would equal 5, right? So is the middle 2 times x times 5? Yes, it is. Yeah. So that means I have x plus 5 all squared equals 0. So according to the zero product property, what does that mean? No. What would I do? Well, you could rewrite it like this if you want. That's what squaring means. Let's see, there's a better equal sign. So either x plus 5 equals 0 or x plus 5 equals 0. But I'm not going to write it twice because it's going to get the same solution both times. So I'm going to get x equals 5. So here's a situation in which I have only one solution. Okay? So that can't happen. Or you could think that I got the same solution twice, if you think about it, right? If I truly set both of those equal to 0. So there you go. Let's see, one last example.
Isn't it x equals -5? Not x.
Oh, what? I'm a sad person. X equals -5. Here we go. It's because it was way down at the bottom of the screen. No, I can't lie. I made a mistake. Good catch, though, friends. You got my back.
Friend, duh.
Thanks, Henry.
Yeah, I heard. Yeah, I heard someone say something first too, but then I was.
August how? Warren.
So, anyways, last problem. What if I have this? What if I've got 3x squared plus 4 parentheses x minus 1 equals 0? So does that mean 3x squared equals 0 or 4 parentheses x minus 1 equals 0? No, because those aren't factored. I mean, this part of it's kind of factored, but I need the whole thing to be written as a product. So I guess we'll distribute this first? 3x squared plus 4x minus 4 equals 0. Let's see, this isn't a pattern. I can't GCF this. The leading coefficient's 3. I think we've got to AC this. Good call.
That would be my fault.
So AC is equal to, well, 3 times negative 4 is negative 12. And I got the factors of 12 are 1 and 12, 2 and 6, 3 and 4. What do I want them to do? I want them to subtract to be 4. That's 2 and 6. I always get scared if it didn't work. Which, by the way, if a problem is not factorable, then it can't be solved by factoring. Okay? But it doesn't necessarily mean it has no solution. It just means that factoring is an insufficient technique for doing that portion of the work. So let's see, let's split the b term into 2 like terms whose coefficients are the factors we just found. Let's see, I think I'll do the 6x and then the 2x because I think the 6 and the 3 are going to be friends. Minus 4 equals 0, still hanging out. Just want to point that out. This equals 0, like, don't just stop writing something because you forgot about it. Like, make sure each line you can connect to the one after it, right? So let's see, what are the signs on these? Well, they multiply to be negative 12, so their signs are different, and the more influential one must be positive, so plus 6 and minus 2. All right, now I do the old factor by grouping, whoop, whoop, and I'll steal a 3x there, and right here, whoop, whoop, and I'll steal a negative 2. Yeah, take that minus sign with us.
Take that whether you want to.
And I'll have 3x times x plus 2. And then minus 2 parentheses, negative 2 times what is negative 2x? X. And negative 2 times what is negative 4?
Minus 2
No, it's plus 2. It's plus 2.
equals 0.
Oh, you're talking. Oh, yeah. You get the right?
Yeah, no, I was
all right.
writing it down and I was talking
Gotcha,
out loud.
gotcha. So, the parentheses match, which they have to. And therefore, I can write x plus 2 as one set of parentheses. And what's in the other set? 3x minus 2, the guys that I just factored out. Now, I've got two things. These two things, they multiply to be 0. So, 0 product property, friends. X plus 2 equals 0, or 3x minus 2 equals 0. Bless you. And, right, so I could break that up into those two cases. And let's solve these. So don't just be all like, oh, the answers are negative 2 and positive 2, because that's not the case. Not the case at all. So I get x equals negative 2. And over here I'd have 3x equals 2. You got it. And actually, a little side note, anytime your answers are rational numbers, that means the problem is factorable. Just so you know. Little inside scoop there for you. And actually, just for fun, let's connect this to our previous concept. So let's see, what was this? 3x squared plus 4x minus 4? Let's say I was to graph the function. All right, what if this was 3x squared plus 4x minus 4, right? And notice that, behold, my parabola, the x-intercepts of this graph are in fact happening at, what, -2 and positive 2/3. Is that the case? Measure the coordinates. Bam, check that out, friend. So I just want to make sure that you realize that the solving by graphing technique still works, but finding an exact answer is kind of a pain. But factoring, when it does work, can find an exact answer. It's kind of nicer. So there we go, friends. Thanks for watching. Solve by factoring, zero product property, ZPP. Yeah, you know me. Bye-bye.